At night, a container port does not sleep. It glows. Floodlights burn through the darkness. Cranes move above the water like giant metal arms. Trucks crawl between towers of containers. Alarms beep. Steel cables tighten. Somewhere inside the noise, a ship almost 400 meters long waits beside the dock, silent and black against the lights. It looks less like a vessel and more like a floating city. From outside, it looks like a wall of green steel. But inside this ship, there is another world. Engines shaking below the deck, hidden ballast tanks, refrigerated containers, fire systems, and a small crew trying to control a floating city. On its deck, thousands of containers are stacked in rows, so tall they seem to block the sky. Inside them are phones, cars, medicine, clothes, frozen food, machines, chemicals, furniture, and factory parts. Parts that factories on the other side of the world are already waiting for. From shore, it feels impossible that something this large can move. Yet before sunrise, this 24,000-container megaship will leave the port. It will carry a mountain of cargo into open water. Out there, one storm, one fire, one wrong loading decision, or one hidden failure can change everything. A smooth voyage can turn into a floating emergency. The ship looks powerful. The ocean sees something different. It sees weight. It sees height. It sees wind. It sees steel bending under pressure. It sees a small crew trying to control a machine larger than most buildings, across thousands of miles of water that can change mood without warning. So the real question is not simply how this ship carries so many containers. The real question is, how does a 24,000-container megaship survive the ocean? How does it survive without breaking apart, losing its cargo, or becoming a disaster no one can stop? The answer is not hidden in one engine, one captain, or one piece of technology. It is hidden in a chain of systems that must all work at the same time. If one link fails, the whole voyage changes. A megaship does not survive because it is fearless. It survives because every danger is measured before it is allowed to become a crisis. The answer begins before the ship ever leaves the dock. At the terminal, every movement is planned. A crane lifts one container from the shore, swings it over the deck, and lowers it into place. It lands with a deep metallic thud. Then another comes, and another. Hour after hour, the ship slowly becomes a wall of steel boxes. To the eye, it may look like workers are just filling empty space. They are not. They are building a puzzle where every wrong move can have consequences at sea. A container ship does not carry cargo like a warehouse. It carries cargo like a tower that must float, bend, roll, and survive violent forces. Heavy boxes must be placed carefully. Light boxes cannot be crushed. Dangerous cargo must be separated. Refrigerated containers need power. Cargo for the first destination cannot be buried under cargo for the last destination. This is why loading begins with something most viewers never see: the stowage plan. It is the invisible map of the ship. Every container has a position. Every slot has a purpose. A 40-foot container may count as 2 standard 20-foot units. So when people say a ship can carry around 24,000 containers, they usually mean 24,000 TEU. TEU means 20-foot equivalent units. The real number of physical boxes can change. It depends on container size, cargo weight, and route. That is why the title of biggest ship can shift as new vessels enter service. But the danger of moving cargo at this scale remains the same. That detail matters, because this ship is not just chasing the biggest number, it is chasing balance. A ship this large is strong, but it is not stiff like a stone bridge. It is more like a long steel body that flexes with the sea. When waves lift the front and back, while the middle hangs over a trough, the hull bends downward. When waves lift the middle while the bow and stern drop, the hull bends upward. The ship looks solid, but in reality, it is constantly bending. This bending is normal. It is designed for it. The terrifying part is what happens if cargo weight is placed badly. Too much weight in one section can increase stress. Too much weight high above deck can make rolling worse. Too much imbalance from side to side can turn a calm-looking ship into a vessel fighting its own load. On land, a bad loading plan may create delays. At sea, it can create danger. Before departure, officers check stability, draft, trim, bending moments, and shear forces. These words sound technical, but the meaning is simple. They are asking whether the ship can stay upright, whether it sits correctly in the water, and whether the long steel hull can carry its cargo without being pushed beyond safe limits. Hidden below the deck, ballast tanks help with this balance. They are like secret lungs inside the ship. The crew can pump seawater in or out of different tanks to adjust how the vessel sits. If one side is too heavy, ballast can help correct the list. If the bow or stern sits too low, ballast can help bring the ship into a better position. This invisible water is part of the cargo story. Without it, the ship would not stand properly in the sea, and once the final checks are complete, the giant begins to move. Mooring lines are released. Tugboats press against the hull. Their engines roar, but beside the ship, they look tiny. Slowly, the bow turns away from the dock. The stern clears the berth. The ship slides into the harbour channel with the careful patience of a moving mountain. Here, speed is dangerous. A vessel this size cannot stop quickly. It cannot turn like a small boat. Its momentum is enormous. The captain, pilot, bridge officers, tug crews, and port control must think ahead, because a mistake made now may not be correctable a minute later. The port lights fall behind. The water opens, and the ship enters the part of the journey where there are no cranes, no docks, and no easy rescue. There are no second chances. Out on the open sea, the containers become a steel landscape. They form narrow canyons along the deck. Rows of red, blue, green, and grey boxes rise high above the water. From below, they look like apartment blocks without windows. Yet these towers are not simply resting there. They are locked into place. Inside the cargo holds, containers slide between vertical steel guides that keep them aligned. Above deck, twist locks connect one box to another. Lashing rods pull the stacks down and inward. Bridge fittings, corner castings, and steel bars distribute forces through the structure. Every small piece matters. A twist lock is not impressive by itself. A lashing rod does not look dramatic. Yet in bad weather, these pieces decide whether the cargo stays with the ship or vanishes into the ocean. The sea does not pull gently. It rolls the vessel from side to side. It lifts the bow and drops it. It throws wind against the container walls. The higher a container sits, the farther it swings when the ship rolls. At the top of a tall stack, even a few degrees of movement can become a violent sideways force. That is why a container near the top is living a different journey from a container deep inside the hold. One is protected inside the steel body. The other is exposed to wind, salt, spray, and motion. If the forces become too strong, lashings can strain, locks can fail, a stack can shift, and once one stack collapses, the failure can spread like a chain reaction. Containers can fall onto the deck. They can crush fittings, damage hatches, or tumble overboard into black water. A lost container is not only lost cargo, it can become a hazard to other ships. It can break open and pollute the sea. It can carry batteries, chemicals, or goods no one wants floating through a shipping lane. The most dangerous container is not always the heaviest one. Sometimes it is the quiet one. A sealed box in the middle of a stack may hold cargo that was packed badly. It may hold cargo declared incorrectly or damaged before it ever reached the ship. Maybe a battery begins to overheat. Maybe chemicals react. Maybe a small flame starts behind closed metal doors where no one can see it. At first, nothing looks wrong. The ship keeps moving. The crew continues their watch. The radar sweeps in circles. The engine beats below. Above deck, thousands of containers stand silent under the night sky. Inside one box, heat builds. Smoke begins to form. By the time an alarm appears or a crew member smells something unusual, the fire may already be hidden deep inside a steel maze. The crew may know there is a fire before they know what is burning, before they know where it started, or how many containers are already affected, and this is where a calm voyage can turn into a floating emergency. Fire at sea is one of the greatest fears on a container ship, because the crew cannot simply call a city fire department. There is no fire truck coming down the street. No ladder crew can surround the flames. The people on board must respond with the equipment they have, with the training they carry, and with the time the fire gives them. Water can cool and suppress, but too much water in the wrong place can create new problems. Smoke can fill corridors, heat can spread through steel, dangerous cargo can react violently. A burning container stack can be difficult to reach, especially if it is high, surrounded, or exposed to heavy weather. The crew has emergency plans, breathing gear, fire systems, and drills for moments like this. Still, every container fire carries uncertainty, and uncertainty is what makes it frightening. Below this risk, deeper in the hull, another world is alive. The engine room is hot, loud, and full of motion. Pipes run along the walls, pumps hum, gauges tremble, metal stairs vibrate under every step. The main engine rises like an industrial monster. It turns slowly, but with enormous force. It sends power through the shaft to a propeller taller than a house. This engine does not just push the ship, it pushes a schedule. Factories may be waiting for parts. Hospitals may be waiting for equipment. Stores may be waiting for products. A delayed ship can disturb a chain that stretches across continents. When a vessel this large falls behind, the delay does not stay at sea. It reaches ports, trucks, trains, warehouses, and customers who never know the name of the ship. Power is only half the story. A ship carrying this much cargo must also fight fuel cost and resistance every mile. The hull is shaped to move through water with less drag. The bow is designed to cut and guide the flow. Energy-saving devices around the propeller can improve efficiency. Some modern vessels use systems that reduce friction along the hull. At this scale, tiny improvements become huge. A small percentage of fuel saved on one voyage can mean large financial savings and lower emissions. But efficiency also creates pressure. Go too fast, and fuel burns heavily. Go too slow, and the schedule suffers. Choose the wrong route, and a storm can punish the ship harder than any timetable. Above the engine room, the bridge watches the world. At night, an officer stands under dim lights. He is surrounded by radar screens, electronic charts, alarms, and dark glass. Outside the windows, the ocean is almost invisible. The only signs of movement are the stars, the faint glow of instruments, and the slow sweep of radar. Those shapes may be ships, storms, or distant coastlines. The sea looks empty. It is not empty. It is crossed by tankers, fishing boats, bulk carriers, naval vessels, drifting debris, and sudden squalls. It is crossed by traffic lanes where every decision must be made early. A megaship cannot dodge danger at the last second. Its size gives it strength, but also makes it slow to react. That is why weather routing becomes one of the most important hidden systems on board. The crew and shore teams study forecasts, wind, waves, current, swell direction, and storm movement. They are not simply searching for the shortest path, they are searching for the safest path that still keeps the voyage alive. A small change in course can reduce rolling. A small reduction in speed can protect container stacks. A longer route can save the ship from the worst part of a storm. To outsiders, this may sound cautious. To the crew, it is survival mathematics. The ocean does not need to sink the ship to create disaster. It only needs to damage cargo, break lashings, start a fire, injure a crew member, or force the vessel to miss a narrow port window. And behind all these systems is a surprisingly small group of people. The accommodation block is the human island inside the machine. There are cabins, corridors, a galley, a mess room, offices, control rooms, and workshops. The crew eats there, sleeps there, works there, and waits there as the ship moves through days of open water. For weeks, their world is steel, salt, machinery, and sky. An engineer may pause in the engine room, listening carefully beneath the noise. He knows the normal rhythm of the pumps and the normal heartbeat of the engine. If one sound changes, he notices. A deck officer may walk under container stacks with a flashlight. He checks fittings and looks for movement where there should be none. On the bridge, another officer may watch radar at 3 a.m. He makes decisions while the rest of the ship sleeps. The ship is huge, but its safety depends on human attention. A strange vibration matters. A failed reefer alarm matters. A loose lashing matters. A shift in weather matters. A small mistake can grow quickly when help is far away. Some containers carry their own climates. Refrigerated boxes, often called reefers, are plugged into the ship's electrical system. They are monitored during the voyage. Inside them may be fruit, meat, seafood, flowers, vaccines, or medicines, cargo that must stay within a narrow temperature range. From the outside, a reefer looks like another steel box. Inside, time is always counting down. If power fails or temperature rises, cargo can spoil. A single container may hold goods worth hundreds of thousands of dollars. A group of failures can become a major loss. The crew cannot open every box and check by hand. They depend on sensors, alarms, inspections, and constant monitoring. This is the strange truth of a megaship. It is both massive and delicate. It can cross oceans, yet one hidden fault can create danger. It can carry thousands of containers, yet every container has its own story. Every container has its own value, risk, and destination. It can look empty from the horizon, yet inside it is carrying pieces of modern life. After days at sea, land returns as a thin line. The ship approaches a major port, and the mood changes. Open water gives space. A port removes it. Channels become narrow. Depth matters. Tide matters. Wind matters. Other ships are close. Berths are scheduled. Cranes are waiting. Trucks and trains are already part of the plan. Arrival feels like the end. In reality, it is one of the most dangerous parts of the journey. A harbor pilot comes aboard to guide the ship through local waters. Tugboats take positions around the hull. The bridge team watches speed, distance, wind, current, and angle. On deck, crew members prepare mooring lines thick enough to kill if they snap under tension. The ship moves slowly toward the berth. Every meter counts. If it turns too late, it may miss the angle. If it approaches too fast, it can damage the dock. If wind catches the container walls, the vessel can drift like a giant sail. The ship that crossed an ocean now has to perform a careful final movement, in a space barely large enough for its own body. Then the lines go ashore. They tighten, the engine quiets, the giant is held, and almost immediately the port begins to take it apart. Cranes descend over the deck. Containers rise from the stacks and swing toward land. Some are placed on trucks, some move to trains, some stay in the terminal for customs. Reefers are connected to power. Dangerous cargo is handled by special procedures. Boxes that traveled across the ocean begin their final journey into cities, factories, warehouses, hospitals, and homes. The ship becomes part of the land again, but only for a short time. Soon it will be loaded again, balanced again, checked again, sent back into the ocean again. This is what makes the story of a 24,000-container megaship so powerful. Its size is impressive, but size alone does not explain how it survives. The real miracle is coordination. The hull must flex without failing. The cargo plan must protect balance. Ballast must hold the ship correctly in the water. Locks and lashings must turn thousands of separate boxes into a single controlled structure. The engine must keep breathing. Weather routing must avoid the worst punishment. The crew must notice small problems before they become disasters. Ports, pilots, cranes, tugboats, dock workers, software systems, customs officers, truck drivers, and rail networks must all connect. And they must connect with almost impossible timing. From the outside, global trade can look automatic. It is not. It is a chain of human decisions, steel systems, and quiet risks stretched across the planet. That is why these ships feel almost unreal. They carry the ordinary things of life in extraordinary ways. The phone in your hand, the medicine on a shelf, the shoes by your door, the machine inside a factory, and the food in a supermarket. All of them may have depended on a ship like this, crossing an ocean in silence. Most people never see the voyage. They only see the product. They do not see the night port. They do not hear the crane cables. They do not feel the hull bending under waves. They do not see the officer watching radar in darkness, or the engineer listening for the smallest change in the engine's voice. They do not see the storm route chosen hours before the first wave hits. Somewhere tonight, another megaship is leaving port. Its containers are stacked like towers. Its crew is small. Its engine is beginning to shake the steel beneath their feet. Ahead of it are black water, storms, currents, fire risks, narrow channels and crowded ports, and thousands of miles where there is no easy rescue. From shore, it will slowly disappear into darkness. Yet inside that darkness, the modern world is still moving, and that is how a 24,000-container megaship survives. Not by defeating the ocean, not by pretending it is stronger than nature, but by respecting every force that could destroy it, and turning thousands of risks into one carefully controlled journey.